This is chapter 511. Let's take all of the different techniques and methods of factoring. And now let's see if we can recognize how we attack each one. Each one's going to be a little bit different. So how do we go about? What's the procedural way of going about it? You know that I listed those numbers. So let's just get right into it. So we look here. Number one, we're always going to see, is it in standard form? We always have to make sure it's in standard form. It is in standard form. Is there a common factor? Yeah, in this problem, there is a common factor. There's a 3x in both of those. If we factor that out, we get x squared minus 4. And now most students would stop. Hey, I factored out a common factor. But as I mentioned in 510, sometimes we have to keep going. So we can look at this. Can this still be factored? So is there a common factor amongst those? No. But we keep going down our hierarchy of criteria. And the next one is special case. So it has two terms. Is it a binomial square? No, binomial squares have three terms. Is it the difference of squares? And yes, it is the difference of squares. It's the difference of two squares. And the criteria are three terms, subtraction, both terms are perfect squares. So this is going to create conjugates. So we get the 3x that just comes down, and then we're going to break up the x squared minus 4 to x minus 2, x plus 2. And now we're finally factored. So understand that we may have to go through multiple times. Is it in standard form? Yes. Is there a common factor? Yes, there is a common factor, 5m, and that leaves us with m squared minus 9. Now we have to keep going. Is it a special case? Is it the difference of squares again? Yes, it is. It is the difference of squares. So that becomes m minus 3, m plus 3. And this is why all that practice earlier in chapter 5 comes to fruition. We have to be able to recognize these relatively quickly so we can be efficient in our factoring. So is it in standard form? A squared A, no A? Yes. Is there a common factor? 3A, 6AB, 3B squared? Yes, there's a common factor of 3. So you get A squared plus 2AB plus B squared. Now, we keep going. We want to see, is this still factored? Can we still factor this? So special cases. Our first was difference of squares. No, this has three terms. Binomial squares. Does it have three terms? Three terms, yes. Is the third term positive? Yes. Are the first and third perfect squares? Yes. And does the middle equal 2 times the square root of the first times the square root of the last? And yes, it does. So if we take that and we take the square root of a squared, which is a, bring down that positive sign, bring down the b, and if we multiply a times b and double it, does it equal my middle? Yes, it does. So this would be the proper notation for that. And that is done. So standard form, we're going to move relatively fast. X cubed comes before x. Common factor, yes, we're going to factor out first term is negative, so we're going to factor out a negative x. We get x squared minus 4y squared. And is it a special case? Yep, it's the difference of squares. So this is negative x times the quantity, x minus 2y, x plus 2y. So remember, that's a perfect square. So we take the square root of that. Remember in the end of chapter 510 that we just did, we had that little trick there. So how we do those. Standard form, yep. Common factor is going to be negative 6z. Negative 6z gives me 2z squared minus 5z minus 3. And now, is it a special case? No. can we do A times C? Yes, A is 2, C is -3, makes -6. 1 and 6, 2 and 3, signs are different. And the bigger is negative, so negative, negative, positive, positive. This gives me -5, that's my middle. So we're going to make this -6z. This is staying, our first stays. My middle gets broken into these two terms. So it's plus z minus 6z minus 3. And now we're going to factor by grouping. We're going to group the first two and the second two. You should be proficient at A times C at this point. So we can take out a z. Actually, let's do this. Let's make that this. We can take out a z. You get 2z plus 1. We're going to factor out a -3, which is 2z plus 1. We did it correctly because these are the same. -6z times the quantity 2z plus 1, z minus 3. You are ready, and you will be really proficient in Algebra 2 in the first couple of chapters if you could get that problem right. That would be impressive. Standard form, yes. Common factor, let's find that's going to be, it's going to be r squared only, and you get 16r squared minus 24r plus 9. And now we see that this is a binomial square. Can you see that? Special case, that's a binomial square. First and third are perfect squares. And we're going to see that the square root of 16r squared is 4r. We're going to bring down that sign. Square root of 9 is 3. And does 4r times -3 is -12r doubled makes -24r. So that's how I saw, that's how I kind of knew that that was going to be. So that would be our answer. That's a good one. I always say that. I love math. Standard form, yes. Common factor. We have 4x, which gives us 5x squared minus 7x plus 2. Special case, no, because no perfect squares. A times C. A is 5, C is 2, 10, factors of 10 are 1 and 10, 2 and 5. Signs are the same. Signs are the same, and they're both negative. So negative, 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 negative. That makes -7. That's my middle. So we get 4x times the quantity 5x squared minus 2x minus 5x plus 2. Let's factor by grouping. And we are going to get 4x. And then let's factor out an x, which leaves us with 5x minus 2. Let's factor out a -1, which is 5x minus 2. 4x times quantity 5x minus 2, x minus 1. Standard form, yes. Common factor. You have a t, which is t squared plus t minus 2. Not a special case. A times c is 1 and -2, which is -2. Factors of 2 are 1 and 2. Signs are different. Bigger is positive. Does that equal? Oh, no. Signs, yeah, different. Bigger is positive. Oh, sorry. -1 plus +2 is +1. But notice, I made a mistake and I slowed down. I didn't just move along and go, well, that's factored, that's prime, we can't do it. I checked, I made sure. I stopped, I slowed down, I went over my work and made sure that I was correct. And I wasn't correct. And I was able to find my mistake because I had written down my work. So we're okay here. This is equal to my middle now because I corrected my mistake. So we get t times the quantity t squared minus t plus 2t. Those two values come from here. That's my negative 1t and positive 2t. And then we bring down the third term, and now we're going to factor by grouping. Nobody's going to be perfect. It's when you make a mistake and you come into a bit of a pitfall, are you able to find your mistake? Are you able to slow it down and take the time to find the error? And did you write your steps clearly enough for you to be able to find it also? So be careful. Standard form, yes. Common factor, 2. X squared minus 64. And that is the difference of squares. Are you able to recognize perfect squares? Yes. X minus 8, x plus 8. Again, standard form. Oh, I already know how this is going to go. Common factor. Factor out of 2, you get x to the 4th minus 81. Watch this. Special case, yes, this is the difference of squares. So you get x squared minus 9, x squared plus 9. Many students would stop here with difference of squares. And now you should loop back around and make sure that you see that this is also, we have one more factoring that we have to do. That is also the difference of squares. You have to be careful. This is not factorable. X squared plus 9 is not the difference of squares. So when we see x to the 4th, we should recognize that's a little bit of a red flag there. We should make sure and see. So standard form, no. So this is another tricky one. This is how I would do it. I know that some people might not do this. Plus 25z to the 3rd. Now I'm going to put it in standard form. That's what I do. I'm going to stick to my guns. Is there a common factor? Yes, there is a common factor. First of all, we have a negative as a first term, so we're going to have to factor out a negative z, and that leaves us with 36y squared minus 25z squared. Now, this is a special case. This is the difference of squares. So you have negative z times the quantity 6y minus 5z, that's not a 6, 6y plus 5z. This is, again, very similar to the problems at the end of section 510. 36 is a perfect square, that's 6 squared. 25 is a perfect square, that's 5 squared. That's why we get the 5z and the 6y. And then conjugates. 2 can come out of there. That's going to be 3x squared minus 11xy minus 4y squared. That's standard form, sorry, common factor, not a special case. 4 is a perfect square, but 3 is not. So we're going to do a times c. A is 3, c is negative 4. 1 and 12, 2 and 6, 3 and 4. Signs are different. Bigger is negative. There's my negative 11. So 2 times the quantity, 3x squared plus xy minus 12xy minus 4y squared. Let's group. Let's group. 2 times the quantity, we're going to factor out an x, which gives us 3x plus y. We're going to factor out a negative 4y. That gives us 3x minus plus y. And we did it correctly because these are the same, which is important. So you get 2 times the quantity, 3x plus y, x minus 4y. Let's make sure we can't factor any further. And that's good. We are done. All right. What are we doing here? Factor completely. Yeah, okay. That leads us to believe that we may have to do multiple factoring. Standard form it is. Common factor. the ax, we can take an ax, which gives us a squared minus 9x squared. Special case, yes, it's the difference of squares. So you get ax times the quantity x minus 3x, a plus 3x. That's good. That's fun. We like when you have to factor completely. Standard form, yes. Common factor, 2x. 2x, 9x squared minus 12x plus 4. Is it a special case? Is it a binomial square? Let's check it out. So we would take the square root of my first, which is 3x. We take the square root of my second, which is 2, and we bring down that sign. And 3x times 2 is negative 6x, doubled equal negative 12x? Yes, it is. If it didn't, then we wouldn't. Then we would try a times c. And I'll show this next one. Next binomial square I'll show you. Sorry. We'll do that though. Standard form, no, it's not in standard form. So we're going to rewrite this in standard form. Then we are going to do a common factor of 5. That's 9x squared, that's a horrible x, minus 12x plus 4. So let's say that we don't see that it's a special case, that we don't see that it's a binomial square. Let's try a times c. Let's pretend we don't see binomial square. So we go to a times c. So we have 9 times 4, which is 36. Factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5, no, 6 and 6. Signs are the same, both are negative. So that's negative 37, negative 20, negative 15, negative 13, negative 12. This is my middle. That's equal to my middle, so we get 5 times the quantity 9x squared minus 6x plus 4. Let's still factor by grouping. We get 5, and now we're going to factor out a 3x. You get 3x minus 2, and let's factor out a negative 3, and we get 3x minus 2. Oops, sorry, that's a brace. And we see that those are the same. You get 5 times the quantity 3x minus 2. Sorry, I'm not factoring out a 3, I'm factoring out a 2. And we get 3x minus 2. Hey, these are the same. So we could write that as 5 times the quantity 3x minus 2, or a binomial square. A little bit longer, and it's why it's good to recognize binomial squares, because it saves you that process there. So keep your head up, keep your eye on the ball, be familiar with all of the different factoring things that we have at our disposal. Recognition for those things is going to save you time, or else you just a little bit more labor intensive. Standard form, yes. Common factor, let's factor out a 6, just a 6, x squared minus 3xy plus 2y squared. Not a binomial square, not a special case. Let's do a times c. A is 1, c is 2, which is 2. Factors of 2 are 1 and 2. Signs are the same, both negative. And yes, it equals my middle. X squared minus xy minus 2xy plus 2y squared. Factor by grouping. Factor out an x, you get x minus y. Factor out negative 2y, you get x minus y. And that becomes 6 times the quantity x minus y times the quantity x minus 2y. Good. Keep going. Standard form, no. 9x to the third plus 63x squared plus 108x. Common factor, yes, there is a 9x, which gives us x squared plus 7x plus 12. I think that's correct. Special case, no. A times c, which is 1 and 12. 1 and 12, 2 and 6, 3 and 4, signs are the same, both are positive. That's my middle. So 9x times the quantity x squared plus 3x plus 4x plus 12. Factor by grouping. Let's factor out an x, we get x plus 3. Let's factor out a 4, we get x plus 3. And my final answer is 9x times the quantity x plus 3, x plus 4. Okay, what are they going to throw us? You feel like they're about to throw us a curveball, right? You feel it's coming. We again need to put it in standard form. So we can't do a times c unless it's in standard form. Let's do the common factor, which is going to be 5k. And that's 2k squared minus 7k plus 5. And now special case, no. A times c. How do I know that it's not a special case? Because these aren't perfect squares. Binomial square and difference of squares both have first and third perfect squares. So that's why I can see when I want to test for a special case or not, is I'm just looking at the first and third. Are they have to be perfect squares. In binomial squares and difference of squares, both the first and the third are perfect squares. So that's how I'm doing, or that's what I'm checking for real quick. And that's a real quick visual. Signs are the same, both are negative. We get negative 7 again. 5k, 2k squared minus 2k minus 5k plus 5. We're going to factor out a 2k. We get k minus 1. We're going to factor out a negative 5. We get k minus 1. 5k times the quantity k minus 1 times the quantity 2k minus 5. And if we want to check, we would check it. Speaking of checking, if we wanted to check to see, we would do these two first. We'd multiply k minus 1, 2k minus 5, which is 2k squared minus 5k minus 2k plus 5. And then we multiply that all by 5k. And we'd simplify inside 2k squared minus 7k plus 5, and then distribute it out. 10k cubed minus 35k squared plus 25k. And is that my starting problem? Yes, it is. Well, in standard form. So that's our check. That's how we're going to check. Also, equally as important, because how much time did it take me to check? 20 seconds? Okay. So being proficient at the factoring provides you opportunities to check your work also. So that's what this speed also provides you. Standard form, yes. That's not 3. 2 is a common factor. There's a common factor of 9, no. 4, no. 6, no. 4, no. All right. 2? 2r. Let's see. 2r squared. And if we factor and we still see that we can do another factor, then do more. 16r squared minus 24r plus 9. I think that's correct. 16, 24, and 9 doesn't have a common factor, so I know that this is the GCF. So that's what I'm checking for here. Now, is it a special case? It kind of looks like the difference, or a binomial square. It looks like a binomial square. So let's check it. We know that binomial squares is going to be the square root of that, bring down the negative, and the square root of that. Does 4r times -3 equals -12r doubled equal -24r? Yeah. So I know that that's my answer. So you don't have to necessarily do middle equals 2 times the square root of the first times the square root of the last. You can produce it and just check. We know how to produce the trinomial of a binomial square. We know how to multiply it out. We should have that down pretty quick. Standard form. A, nope. So that's -12a squared plus 12ab minus 3b squared. Now you're in standard form. Now I'm looking for a common factor. I have a negative I got to get rid of and a 3. So this is 4a squared minus 4ab plus b squared. And is that a binomial square? Is it a special case binomial square? So -3, so 2a minus b, quantity squared, that's doubled, -4ab. So that's how fast, yes, look at that. Ooh, we have 4 terms. So first, standard form, you have b, c squared, b, c squared, and then a constant. So b and b are tied, so we're going to throw the c squared in first, so that's good. Is there a common factor? No. Is it a special case? No. Can we do a times c? No, a times c is with 3 terms. So 5 is factor by grouping. Oh, let's factor by grouping. We'll factor out a b, and we get c squared minus 4. Ding, 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 ding. You should recognize that. Factor out a 3, we get c squared minus 4. C squared minus 4 is in both of those binomials. We're going to factor that out and get b plus 3. And we are not done. After we did that, we got to go back. And we see that it's a special case. That's the difference of squares. So this is c minus 2, c plus 2, b plus 3. Oh, that's a thing of beauty. So standard form, nope. X cubed plus 6x squared minus x minus 6. Common factor, no common factor. Has to be in all 3, or all 4, excuse me. Hello, 4. Special case, no. A times c, no. Factor by grouping, yes. So let's factor out an x squared, you get x plus 6. Let's factor out a -1, you get x plus 6. And x plus 6 times the quantity x squared minus 1. We can still factor, factor. So that is the difference of squares. So x plus 6 times the quantity x minus 1, x plus 1. Standard form, x squared, x, y squared, 16, good. Common factor, no. Special case, no. A times c, no. FBG. Let's factor out an x, you get x plus 6y. Let's factor, ooh, oh my. You can't factor anything but look at this, people. This is the difference of squares. But, so this is plus 3x minus 4, 3x plus 4. But they don't have that in common. So, okay, that was a little tricky. Let's see, can I move things around? Yeah, there's nothing in common. No common, no common, no common. So this might be prime. I might say that this is prime. You can shuffle these around. That's not a bad thing. You might want to put the x squared with the 16, and then this, no, it's going to be 2 and 3. So yeah, no common. So I'm going to say that that is prime 23. We'll have to check that one later. That might be a trick one. So standard form, yes. Common factor, no. Special case, no. A times C, no. And factor by grouping. Let's try factor by grouping because it has 4 terms. We'll take out an a squared. You get a plus b. Let's factor out a negative b squared, and you get a plus b. Now this worked. So that's a plus b times the quantity a squared minus b squared. And we see that we can still factor. That's a plus b, a minus b. And I would write this as the quantity a plus b squared times the quantity a minus b. I would write it as, because I have 2 of them, you should have 2 a plus b's. So I'm going to write that in that manner. I'm just going to be a stickler. Standard form, yes. Common factor, no. Special case, no, not a perfect square. A times C, yes. 3 terms. A is 1, C is 20, which is 20. Factors of 20 are 1 and 20, 2 and 10, 4 and 5. Signs are the same, both negative. Negative 9. So we get y to the 4th minus 4y squared minus 5y squared plus 20. Factor by grouping, we're going to take out a y squared. You get y squared minus 4. We're going to take out a negative 5, which gives us y squared minus 4. Y squared minus 4 times the quantity y squared minus 5. This is difference of squares. So we get y minus 2, y plus 2, y squared minus 5. Coming down, standard form, yes. Common factor, no. Special case, ooh, special case could be a binomial square. My first and third are perfect squares. My third term is positive. So let's see, is it x squared? Bring down the negative square root. And does those 2? No. So this times this double does not equal this. No. So not binomial square. So we do away with that. And now we go to 4. Let's say a no. So let's keep going. A times C. It still might be A times C. So A is 1, C is 9, which is 9. Factors of 9 are 1 and 9. Signs are the same, both negative. Oh, bingo. That is my middle. So this is a great example of where it was not a binomial square, but I could move on and do A times C. Negative x squared, negative 9x squared, plus 9. Let's factor by grouping. We're going to take out a x squared. We get x squared minus 1. Take out a negative 9. You get x squared minus 1. Oh, wow. A lot of work here. A lot of extra. This is really good, though. X squared minus 1 times the quantity x squared minus 9. Hold on. Difference of squares. Hold on. Difference of squares. X plus 1, x minus 1. X plus 3, x minus 3. Oh, you little trickster. So that was a real good one. Was that the last one? No. Woo! Lots of stuff. Lots of things to mess around with there. Again, is it a binomial square? Is it x squared minus 6 quantity squared? That equals negative 6x squared times 2 equals negative 12x squared. Not equal to my middle. Not equal to negative 13x squared. So not binomial square. So let's keep going. A times C. So now we go back to A times C technique. 36, factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Signs are the same, both negative. Negative 12, negative 13, negative 15, negative 20, negative 37. This is my middle. So we're going to make this x to the fourth. Let's use these two terms. Minus 4x squared minus 9x squared plus 36. That's correct. Let's factor by grouping. Take out an x squared, you get x squared minus 4. Take out a negative 9, you get x squared minus 4. We already see, hopefully you see how this is coming out as multiple difference of squares. Again, difference of squares, that is also difference of squares. So we get x minus 2, x plus 2, x minus 3, x plus 3. All right, what are you going to throw me now? This is binomial square. Standard form, common factor, special case binomial square. I think it is. X squared minus 12 quantity squared. Yes, so we're done. That's the night, right? Look how fast we can do that. So that is a binomial square. Is this a standard form? Yes. Common factor? No. Special case binomial square. You have b squared minus 4 quantity squared. So that is yes. And notice, hello. However, this is difference of squares, you little stinker. So this is going to be x, b minus 2, b plus 2, and we're going to have quantity squared because we have 2 of them. And I would just write this as b minus 2 quantity squared, b plus 2 quantity squared. All right, that's a good trick one. So standard form, yes. Common factor, no. Special case, no. A times C, no. Factor by grouping. We're going to factor out an a squared. We get a plus 2. We're going to factor out negative 5. We get a plus 2. A plus 2. A squared minus 5. That's it. I do that one as our last problem. Did I do it correctly? I think I did. Yeah, I did it correctly. Well, that's kind of lame-o. Okay. They threw us all those hard ones and then gave us this super easy layup for number 30. Okay, that's your first real litmus test. Do you understand chapter 5? How well did you do in that worksheet?